This is 100 tons of TNT. This is a humongous explosion, beyond what most of us will ever see in our lifetimes. But why does it do this? That's what we're here to tell you. This is the chemical structure of TNT, also known as 2,4,6-trinitrotoluene. Now, the reason that it's so explosive is because of the N2 bond. There is a triple bond between each of the nitrogens, and that is why it is so explosive. Based on just that information, one might say, well, aren't triple bonds more stable than any other bond? Yes, that's true, but that's also what makes nitrogen-based compounds so explosive. Because of the formula for enthalpy of reaction, which is sum of bond enthalpies of reactants minus the sum of bond enthalpies of the products, the enthalpy of formation value of the nitrogen triple bond is 941 kilojoules per mole, which makes it very strong, and since it is a product, nitrogen-based reactions will react very exothermically. The bond enthalpy of the triple bond between the nitrogens is so strong and stable because of the multiple pi bonds and the sigma bond. To illustrate the power of these nitrogen-based compounds, we have done an experiment involving nitrogen triiodide. Nitrogen triiodide is so reactive due to its weak bonds. This is because the nitrogen atom is very small and the iodine atom is very large. Because of this, the covalent bond between the nitrogen atom and the iodine atom is very weak because the iodine atom is so big it is hard for the electrons to be shared between the two atoms. Another reason the bond is so weak is because of the electronegativity values of nitrogen and iodine. Since their values are very similar, the bond between the two is not very polar, which makes it very weak. Because of that, this happens. To make the nitrogen triiodide, we got 0.50 grams of iodine solid and crushed it up to increase the surface area, which therefore allowed it to react more fully. We then used 0.880 molar ammonia solution that we created to react with the iodine crystals and to be stirred for 5 minutes. That would create the nitrogen triiodide solid that we needed. Now, nitrogen triiodide is only explosive when it is not wet with the ammonia solution. So, in order to get it into a spot where we could dry it, we put it into a piece of filter paper with a funnel and an Erlenmeyer flask. Then we let the ammonia solution drip into the Erlenmeyer flask while the nitrogen triiodide was trapped in the funnel. Now, some nitrogen triiodide remained in our small beaker, and so in order to remove it, we had to use a small amount of ammonia pushed in by a pipette to get the remainder of the nitrogen triiodide solution, or solid, into the funnel. The original plan that we had made when creating this lab was to touch the nitrogen triiodide with a feather to make it explode to show how volatile it is. Now, it turned out that after the 5th try we realized we had made it a little too well. Each time we tried to make it, due to the humidity in the room, the small amount of water droplets that existed in the air was enough to set this thing off. It was so reactive. So, day after day after day, we created the same nitrogen triiodide, and we kept messing it with the camera until now. So, we are now showing you the length of the nitrogen triiodide before we got to it, while we were still waiting in other class periods. Other periods of Mr. Williams' class were going by, actually, and we were running through the entire time, and here is a sped-up version of what happened while we were away. Once we made it back to our nitrogen triiodide sample, we found that it in the state that you currently see now, and thought that it had all exploded. And so we said, before we pick it up, why don't we test and make sure that all the explosives are gone? And here's what happened.
Oh, I don't know if I got it.
Because the explosion was so fast, we gave you a slow-mo version so you could get a better view of what happened. And to show you how powerful it was, we have a hole in both the aluminum foil and the protective covering. Alright, thank you guys for watching, and I hope you learned something about nitrogen triiodide and why nitrogen is used in contact explosives.